Continuing with the Math 1314 Final Exam Review, number 71, solve 5 to the 3x minus 1 equals 17. I've isolated the exponential on the left. Now I need to take the log of both sides. I'm going to choose to take log base 5 of both sides because on the left hand side when I do that, log base 5 of 5 to the 3x minus 1 leaves me with 3x minus 1. So I have 3x minus 1 equals log base 5 of 17. To solve for x and get x by itself, I need to add 1 to both sides. So I get 3x equals log base 5 of 17 and then plus 1 out to the side. If you need to put parentheses around this so that you don't do that 17 plus 1, do it. Log base 5 of 17 is a number and you want to find that number first, then add 1 to it. Okay, back to isolating x on the left. I need to divide both sides by 3. So my answer will be x equals log base 5 of 17 plus 1 all divided by 3. For number 72, solve log of 5x minus 6 equals 10. You know that this is the common log, so this is base 10. That base 10 is understood to be there. But I need to go ahead and write it in so that when I convert to exponential, I see that I have 10 to the 1 equals 5x minus 6. So if I want to get x by itself, I need to add 6 to both sides. 10 plus 6 is 16 equals 5x. Dividing both sides by 5, I get x equals 16/5. Now, since this is a log equation, I need to check my answer. I'm going to cheat with my calculator and store 16/5 as x, and then I just type in my original equation, log of 5x minus 6 equals 1. If the answer on the calculator gives you a 1, that means it's a true statement, so yes, that solution worked. If the calculator had spit out a 0, that would have meant false and the answer would not work. You'd have to cross it out. Quick lesson on how do you get the equal sign on your calculator. You're going to hit second math, and above math says test, so you're hitting second test, and then number 1 is the equal sign. Just hit enter and it will put the equal sign on your home screen. Number 73 says to solve natural log of x minus natural log of x minus 7 equals natural log of 2. I see that I have natural logs on both sides. I want to combine the left-hand side into one natural log. Since I have natural log of x minus natural log of x minus 7, I'm going to use the log property and say that that's equal to the natural log of x divided by x minus 7. Now recall that there's a rule that says if natural log of m equals natural log of n, then m must equal n. So I'm going to now get rid of my natural logs on both sides. I have x over x minus 7 is equal to 2. Multiplying both sides by x minus 7, those cancel, and I'm left with x equals, and I'm going to distribute 2x minus 14. If I add 14 to both sides, I get x plus 14 is equal to 2x. Now I need to subtract x from both sides, and I get x equals 14. Sorry. Okay, continuing on, I get x equals 14. The reason I apologized, over here on the right hand side, I had stored 7 for x for some reason. And when I tested it and said ln of x minus ln of x minus 7 equals ln of 2, I got an error. So that told me that x equals 7 was not a solution. But when I typed it in again, okay, when I typed it in again to my calculator, and this time I actually typed in 14 for x and typed in my equation, I got that it was true. So x equals 14 is a solution to that equation. Number 74 says the growth in population of a city can be seen using the formula P of t equals 2,148 times e raised to the 0.008 t, where t is the number of years. Use this formula to calculate the population after 10 years. So you're wanting to find P of t. So you'll type in t equals 10. So 2148 e to the 0.008 times 10. When I enter that in on my calculator, I get the population will be 2,326.9. Number 75 says, how long will it take a sample of radioactive substance to decay to half of its original amount if it decays according to the function A of t equals 200, e raised to the negative 0.187 t. So I want half-life. So if I start with 200, notice that the constant out here is the initial amount, because if I plugged in 0 for t, e to the 0 is 1. 200 times 1 is 200. So a of 0 is 200. That is the initial amount. That's how I'm getting that. So if I want to know how long it'll take to get to half of that amount, when will the amount equal 100? So I'm trying to solve 100 equals 200 e to the negative 0.187 t. I need to isolate the exponential. How do I do that? First I have to divide both sides by 200. 100 divided by 200 is 1/2 is equal to e to the negative 0.187 t. Now I need to take the log of both sides. I'm going to use log base e, in other words the natural log. So I get the natural log of 1/2 is equal to negative 0.187 t. And the reason why over here, just to remind you, I have log base e of e to the negative 0.187 t. Remember that the natural log is log base e. And log base e of e raised to a power is just that power. Okay, now to get t by itself, I need to divide both sides by negative 0.187. So t is equal to the natural log of 1/2 divided by negative 0.187. And when I type that in on my calculator to get a decimal approximation, I get that t is approximately 3.7 years, or whatever your unit of measure is. Number 76 says, how long will it take $2,100 to grow to $42,600 at an interest rate of 3.2% if the interest is compounded continuously? Round the number of years to the nearest hundredth. So we're going to use PERT because it was continuous compounding. I want $2,100 invested, and I want the amount after t years to be $42,600. It was invested at 3.2%. So solving for t, first thing I need to do is divide both sides by 2,100. So I'm going to write 426 divided by 21 is equal to e to the 0.032 t. Then I'm going to take the natural log of both sides, and I get the natural log of 426 divided by 21 equal to 0.032 t. Now I'm going to divide both sides by 0.032, and I get the natural log of 426 divided by 21, all divided by 0.032 is equal to t. When I type it in on the calculator, I get approximately 94.06 years. Number 77 says to solve the system using your choice of method. So I'm going to go write this as an augmented matrix. And how do I do that? I put the coefficients. So the coefficients going across on the first row will be 1, -1, 2, -9. Going across the second row will be 2, 0, 1, -3. Going across the third row, I get 1, 4, 1, 9. I type that matrix into my calculator, and I do RREF of that matrix, and this is what comes out. So I have 1, 0, 0, 0, 0, 1, 0, 3, and 0, 0, 1, -3. Again, what's important on my calculator is this column, 0, -3, 0, 3, -3. So my solution is the ordered triple 0, 3, -3. Number 78 says to write the augmented matrix for the system, but do not solve it. So again, my first row is going to be 4, 0, 2, 50. My second row is going to be 0, 9, -2, 63. And my third row is going to be 2, 2, -2, 16. That's the augmented matrix. Number 79 says to use Gauss-Jordan method to solve the system of equations. For time's sake, I'm going to go solve it on my calculator. I need to write the augmented matrix into the calculator, and I'm going to walk you through doing that. On your home screen, if you'll type second matrix, notice the matrix button is 2 below your alpha button. I'm going to arrow over and edit and hit enter. I'm going to edit matrix A. It's going to have 3 rows and 4 columns. So if yours doesn't say 3 by 4, you need to type in 3 by 4. Now type in the rows. Type in the coefficients. And for number 79, the coefficients were 6, -1, 4, 25, 9, 8, -9, 108, 7, -4, 1, and 0. I've already typed those in just to save time. Once you have your numbers into your matrix, hit second quit. Now you want to go do RREF, row reduced echelon form of that matrix. So I'm going to hit second matrix, arrow over to math, and arrow down to RREF. Which is letter B. Hit enter. Now I want to tell it to do RREF of matrix A. So again, do second matrix. And your matrix A is already highlighted, so hit enter. Close your parenthesis. And there's your row reduced echelon form of that matrix. Again, what's important is over here on the last column. So going back to my work, I showed you that I entered the matrix into the calculator, and this is what the row reduced echelon form looked like. So my last column over here, I see that I have a diagonal of 1s here on the left hand side and 0s above and below. So my solution is that last column. It's the ordered triple 5, 9, 1. X is equal to 5, Y is equal to 9, Z is equal to 1. Number 80 says to find asymptotes. The denominator, when the denominator equals 0, I get a vertical asymptote. So x minus 7 equals 0, x equals 7 is a vertical asymptote. Because the degree of the numerator is 2, the degree of the denominator is 1, the degree of the numerator is bigger, so horizontal asymptote, there's none. But since the degree of the numerator is 1 bigger than the degree of the denominator, there's going to be a slant asymptote. How do you find it? You need to do long division. X squared plus 2x minus 5 divided by x minus 7. You say x times what gives you x squared? Well, the answer is x. So now you're going to go do x times x minus 7. And you get x squared minus 7x. To subtract, you need to change the signs. X squared minus x squared, that's gone. 2x plus 7x gives you 9x. Bring down the minus 5. Now ask x times what gives you 9x? And the answer is 9. So now you do 9 times x minus 7, and you get 9x minus 63. Sorry, I erased that 9. You get 9x minus 63. To subtract, change the signs. 9x minus 9x is gone. Negative 5 plus 63 is 58. You don't really care about that though, because your slant asymptote is going to be y equals x plus 9.